Hi, this is section 2.2. In this section, we talk about intercepts and symmetry. Now, a lot of people see this section as a section that really doesn't look that hard, and it isn't. It's a very important section, though, because what we do here, we do a lot of throughout the course, and that is by finding the intercepts. Okay. The title of this one is basically Intercepts and Symmetry. The one thing I will tell you, we talk very little about symmetry at all. It won't be on the final exam at all. And so what I'm going to do is I'm just going to mark it out, even though I want you to understand that symmetry is a part of the discussion in this section, although we're not going to spend any time at all with that. The objectives that we're going to cover is finding the intercepts and then graphing the equations by use of the intercept as well. Now, this is something you did in intermediate algebra or algebra 2 in high school, if that's where you're at. Find the x-intercepts and find the y-intercepts. When you find the x-intercepts, you have to set the y-coordinate equal to 0 and then solve for x. And when you're finding the y-intercepts, you set the x-coordinate equal to 0 and solve for y. So I gave you 3 examples here. And example 1 is very simple. It's finding the x and y-intercepts based on a graph. And that's very simple. Since this is the x-axis, this is the y-axis. The x-intercepts is where the graph touches or crosses the x-axis. So in this case, the x-intercepts are going to be at 3, 0. This point right here, that's the location of that point on the Cartesian plane. And this one's negative 3, 0 right there. That's the location of that point. So it's just kind of observe and write down. And then the y-intercept are going to be 0, 2, 0 up 2. And when you're doing this, you have to write down, and the y-coordinate is 0, negative 3 looks like. So it's not quite in the ellipse, but it's close. So 0, 2, and 0, negative 3. But when you're finding the x-intercepts, you have to make sure you put the x equals 2 and the y-coordinate is 0. And when you're finding the y-intercepts, the x-coordinate has to be 0. You can't just say y equals 2 and y equals negative 3. That means something else. We talk about asymptotes a little bit later on in the course. So when you write x and y-intercepts, you got to write them as ordered pairs, not as equations. Example 2, find the intercepts. So this is where we're going to use this. When you find the x-intercepts, you set the y-coordinate equal to 0. So if you do that, so find the x-intercept, you set the y-coordinate equal to 0. And then you solve, and you get 5x equals 30 because 6 times 0 is 0. And then divide by 5, and x equals 6. So you can't just leave it as x equals 6. You can't leave it in an equation form. It's a point, so it's an x-intercept, so it's 6, comma 0. And then the y-intercept, find the y-intercept, you set the x-coordinate equals 0. So to be 5 times 0 plus 6 times y equals 30. And so 6y equals 30, divided by 6, and y equals 5. So the location is 0, comma 5. Now, once we're going to be talking about something very close, very soon, is something about lines. And again, that's another Algebra 2 concept, so it's not as if it's really new or anything. But these are 2 points on the graph. Okay, so in the next example, we're actually going to do a graph. But this one, that's all they want is the intercepts. So this is when we're done. But at the next level of the problems, where it's to graph this problem, you would actually locate those points on the Cartesian plane. In this case, it's here 6, 0 and 0, 5. And since you know this is a line, and you'll learn that in 2.3, you would just connect those 2 points with a line. And a lot of people will get to an algebra class and draw these graphs and really don't know what the graphs really indicate. The graph is a solution, because every point on the line is a solution to the equation. So not just 6, 0 and 0, 5. These are just 2 of the many points that work. So this point right here, I can't tell you exactly what it is because it's kind of in between, but I will tell you one thing about the point. The point is a solution to that equation. But I can tell you something else about this point. Not only is that point not on the line, but since it's not on the line, it is not a solution to the equation. So in essence, what a graph or what a line or whatever you're dealing with, what kind of the graphical image you're looking at, the graph is a representation of all the solutions to the equation. So I'm kind of getting a little ahead of myself. This is something very important when you're doing graphs later on, and this is what this section is all about, is giving you the very preliminary things about a graph. And so, and every graph that you're going to be doing in this course will discuss x and y intercepts. So whether they're lines or whatever. The next one is graphing by finding the intercept. So you did it exactly like you did example 2. So if you find the x-intercepts, you have to set the y-coordinate equal to 0. So 0 plus 2x squared equals 8. So you get x squared equals 4. And from a previous section, back in chapter 1, we noticed that was x equals plus or minus 2. So the x-intercepts are 2, 0, and negative 2, 0. So there's two locations, there's two x-intercepts. And yes, a graph can have two x-intercepts. Okay? And then the y-intercept would be setting the x-coordinate equal to 0, so it would be y plus 2 times 0 squared plus, equals 8. And it looks like it's just y equals 8, so 0, comma 8. So how example 2 and example 3 is different, example 2 did not require the graph. Example 3 does. So when you graph this, it's going to be negative 2, 0, plus 2, 0, and then 1, 2, 3, 4, 5, 6, 7, 8. Now, the thing about this is, if you don't know what kind of a graph this is, you're going to find some additional points. But if you know what this kind of graph is going to be, and this is actually a parabola, and you're like, well, how am I supposed to know it's a parabola? Well, technically you don't have to know that, but if you don't, you're going to have to plug some additional points in, and then you'll have to determine what that graph is going to look like. But if you've had a little bit of experience with this stuff, you will know that the graph actually does this. And remember what this is. This is a representation. So when I did that shape, and let you guys know the name of it, it's called a parabola. And that parabola has a set of points. And that point that is on that parabola satisfies this equation. So this ordered pair right here, may not know what it is. Let's call it A comma B. Okay? If you plug A in for the x and B in for the y, whatever those numbers are, since that point is on the parabola, it would equal 8. But if a point is not on there, if you put another like over here, like a C comma D, since C comma D is not on the parabola, you put C in for the x and D in for the y, you don't get 8. So that's what a graph represents, the solutions of the equation. So anyway, 2.2 is very simple. When you do your homework, you're going to say, oh, this is pretty easy. But I want you to understand this is basically the baby step of all the graphs that come later. So everything will have this in common. And when you're reading the book and reading the notes, remember symmetry, we do not discuss. So at least very little anyway. So anyway, that is 2.2.